Hello everyone, welcome to BioBrain. Today we're going to be learning the easiest way to find the vertical and horizontal component of a projectile motion and the final velocity and the value of angle theta. Alright, so the first thing I want to do in this case, I said a ball is kicked horizontally with a velocity of 20 meters per second from a height of 2 meters. Calculate A, the vertical and horizontal component, B, the final velocity and the value of theta, of angle theta. So what you want to do now is that you want to find the value for the vertical and the horizontal. You want to bring out your parameter for the vertical and the horizontal components. All right, so we know that our velocity for the vertical was not given. Our initial velocity for the vertical was not given also. All right, but over here our velocity for the horizontal, they said a ball is kicked horizontally with a velocity of 20 meters per second. Right, you know this is initial velocity because it was kicked. Right, they said it was kicked. All right, so that's the initial velocity. All right, so we have the u is 20 meters per second. Then v was not given from the question. All right, then from a height of 2 meters. All right, from a height of 2 meters, we know that is the vertical. All right, that's the vertical component. So we have sy 2 meters. All right, over here we don't know the distance in the horizontal component. Then the time, we don't know the time. We're not given time. All right, so I have to find the time. But you need to know that for the vertical component, the gravity is 10 meter per second, right? Acceleration due to gravity is 10 meter per second. Then for the horizontal component, acceleration due to gravity is zero, all right? So now let's find from our given parameters, let's find the time, right? So we know our formula for we can find the time by saying t is equals to root 2h over g, right? Because we're given distance, and we're given we know our gravity. We know for the vertical component, our acceleration due to gravity is 10 meters per second. So we can as well say this 2 root 2 times for our height is 2 over 10. So we're having t is equals to root 4 over 10. This is now t root 0.4. This is now t. When you take the square root of 0.4, you'll be having 0.63255 seconds. All right, okay, seconds. So you'll be having 0.6325 seconds. So we found our time. Our time is 0.6325 seconds. So now we can find our velocity for our vertical component. All right, we can find our velocity for the vertical component. So we can say this vy is equals to u plus at or gt. So this is vy is equals to our u now. Okay, from our question, they said a ball is kicked horizontally with a velocity of 20 meters per second from a height of 2 meters. Right? So you need to understand that they didn't give us our u for the vertical component. Our u for the vertical component, which is the initial velocity for the vertical component, will be zero. It will be zero because it was kicked horizontally. That means initially the vertical component for the our vertical component for the u is zero. Alright, so you need to understand that the vertical component, which is u, is zero. Then for our gravity, this 10 times our time, 0.6325. So one punch our calculator will be having 6.325 meter per second. Alright, so this is your velocity for the vertical component. Alright, so we have 6.325 meter per second, and here we have zero. Alright. Alright, so now let's find our velocity for the horizontal components. Alright, so we have vxu plus gt. Vx is equals to our our initial velocity for the horizontal component is 20 plus. You know, our acceleration due to gravity in the horizontal component is always zero, right? You need to know that the acceleration due to gravity in the horizontal component is zero. So here we're having zero. So Vx is 20 meter per second. So we're having that the horizontal velocity is 20 meter per second. So now let's find our horizontal distance. So we have x is equals to ut plus half at square. So we have fx is equals to our u, we're having 20 times our t, 0.635 plus half times our acceleration, which is 0, times our t, which is 0. This is 6325, 0 0.6325. All right, so we're having x is equals to, when you punch your calculator, you'll be having 12.511 meter. Right, so this is the horizontal distance. All right, this is the horizontal distance. So we successfully found the vertical and the horizontal components. Now let's find the final velocity. How do we find the final velocity? Okay, so we have to draw a right angle triangle. So we know that our Vx, we got our Vx to be, our Vx was 20 meter per second, 20 meter per second. Then our Vy was 6.325 meter per second, right? So we have to find our final velocity now. Now, from our Pythagoras theorem, we know that v square is equals to v y square plus vx square, right? From Pythagoras theorem. So we're having v to the root vy square plus vx square. So we're having v is root. Now our vy, this is the vertical component, which is 6.325 square plus this is now 20 square. So we're having v is equals to root. When you punch your calculator, this will give you 40.005625 plus 400, right? So we'll be having v is equals to root 440, and we have v is equals to 20.98 meter per second, and this is your final velocity. All right, so solving the c part now, they asked us to find the angle theta. All right, so to find the angle now, we can say tan theta is equals to, we know from our SOHCAHTOA, tan is opposite over adjacent, right? So we know that our opposite here is 6.325 over 20, right? Which is the same thing as saying vy over vx, which is equals to 6.325 over 20, right? So we have tan theta is equals to, when you divide both of them now, you'll be having 0.31625. Then theta is equals to the tan inverse of 0.31625, right? When you punch your calculator now, you'll be having 17.55 degree, and this is your final answer for this, right? If you found this video helpful, make sure to hit the like button and make sure you subscribe to this channel. Right, see you in the next video.